Very good evening. I'm Lydia Hallie. I'm a staff developer advocate at Vercel. And today I'll be talking about rendering at the edge, or kind of just like anything edge with Vercel. Now, but before I talk about this more kind of cutting edge rendering approach, I want to take a step back and talk more about the common rendering patterns that we see nowadays, and also how the edge can actually solve some of the issues that we're facing. If you've seen my talk at Reactathon, a lot of this content may already look very familiar to you, but I actually added some more like edge-specific stuff at the end. So when we're building an application, ideally we just want to develop, preview, ship, make our users happy, and just generally, have a successful product to share with the world. But unfortunately, in most cases, it doesn't quite end up that way. We might accidentally introduce really long build times, have frustrated users because our website is really slow or it has a really jumpy UI, and we can't even get a huge server bill at the end of the month for a project that didn't even gain traction because the website never got a great SEO because the performance was so bad. So although our idea might have changed the world, the way that we architected our app prevented that from ever happening. So what can we do about this? Well, we have to start implementing the right rendering patterns in our application. Knowing how to apply these techniques and also which tools to use can really improve your app's performance, like user experience, developer experience. So when we talk about web performance, usually we think about optimizing for the core web vitals. And these are a set of useful measurements that we can use to see how well our site performs. So we have like the TTFB, or time to first byte, which measures the time it takes for the server to respond with that initial data. And then we also have the FCP, or first contentful paint, which measures how quickly your users see your content to the screen for the first time. I won't go over all of these, you can read. But I want to, if you want to have a website that has a great user experience, but also has a great SEO, Google likes it, we have to start caring about optimizing for these core web vitals. But that's not all, because we also want to have a great developer experience. We want to have a project with short build time so we can iterate quickly. We want to have low server costs so we don't go bankrupt after a week of launching. And we also want to show dynamic content in a performant way. And generally just no scalability issues if our website suddenly goes viral on TikTok or Reddit, whatever. Now, although this might seem like a lot to keep in mind, I know those animations are so bad on the screen, but whatever. Using the right rendering technique can really help you create a good user and a good developer experience. Okay, so now we know why these rendering patterns are so important, but how do you know which one makes the most sense for your website? Or if you are using Vercel or Next.js, you know that you can even use it on a per page basis. So how do you know, okay, this one makes the most sense for that page or my application? Now, if you've been a front-end developer for a while, or you've used Next or Vercel, you may know that there's a lot of different techniques that you can choose from, a lot of abbreviations, lots of opinions from people on them as well. So today I'll be covering some of the most common ones and how we can use them, and also see at the end how the edge might improve some of them. First, let's talk about one that's very basic and straightforward, at least it seems like it. It's static rendering. Sorry, I'm still out of breath from those stairs that I had to walk up here. So there are actually many variations to static rendering when we use Vercel. So static rendering is, of course, a very popular pattern because it comes with so many performance benefits. So with static rendering, the entire HTML gets generated at build time. And since the files are static, they're also easily cacheable by a CDN, or Vercel is actually the Vercel Edge network. Now let's see the variations to it. So first off is, of course, there's plain static rendering. So if you, for example, have this this fake demo real estate website, this page is perfect for static rendering because it just shows the same data for everyone globally. We aren't fetching any data or showing any personalized components. So when we deploy this, so in this case to Vercel, the HTML gets generated for all the pages and then persisted to static storage. So when a user visits this website, a request is made to the server. I don't know how this looks now here, but anyways. And the server can quickly return this pre-generated HTML to the client. And as it gets returned, the edge also caches this to the location close to the user. So the browser can render this HTML and optionally request a JavaScript bundle to hydrate a page, so to bind these event handlers to that static HTML. So from a performance perspective, this is of course a great approach because we can have a very fast time to first byte since the server already contains this pre-generated HTML. The browser can also quickly render something, resulting in a fast first contentful paint and largest contentful paint. We also don't have to worry about layout shifts because we're not dynamically loading content. So plain static rendering is great for your core web vitals, but of course in most cases we want to show some dynamic data. Say that instead of showing some services here, we actually want to show some of the recent listings. Now, we could, of course, just hard code that in the page right there, but in reality, we probably want to use some kind of data source to fetch these listings from. So one approach we can take here is to use static rendering in combination with a client-side fetch. So we can simply, statically render the website like we did before and just fetch that data client-side as soon as the page is done loading. So to fetch the data in a performant way, we can, for example, use SWR. So while the data is being fetched, we'll just show a skeleton component. So now when a user requests a page, the server again returns this pre-generated HTML, and the users will initially see that skeleton UI. This skeleton UI is also cached by the Edge network. So after parsing and rendering that initial content, the browser fetches the data from that API route, and then the listings are actually visible to the screen. And of course, there's also that hydration call, which I'm not including in this case. So again, static rendering and fetching client-side gives a really good time to first byte and also good first contentful paint, but that largest contentful paint is not as good as it used to be because we actually have to wait for the API route to return the data before it can actually show those listings. And we can also run into layout shifts, which can happen if our skeleton components don't match the components that we actually render to the screen after the API route has responded with data. When you use Next.js, you can actually choose between a few more static approaches that really improve the performance of your app when you work with this dynamic data. So the first approach is to use this getStaticProps method. So this method runs server-side at build time. So we can directly call our data provider right in this method. So if your data is available at build time, this can be a really good solution to add this dynamic data to a static page. So now when we build the project, the data provider gets called and then returns this path to the generated HTML. Sorry, my computer is like. So now when we request a page, we again fetch this HTML from the server, the response gets cached, rendered to the screen, and the browser again sends a request to hydrate these components. So the network and main thread are identical to what we saw before with just plain static rendering. So again, from a user perspective, we get a great performance, but from a developer perspective, we can quickly run into some issues. Because imagine that we statically generated thousands of pages, which can easily happen if we have maybe an e-commerce website or a blog. Or if you're using an external API, you can also easily hit the request limit, or if they charge per call, this is going to be very expensive. And also another issue is that we're only renewing the data at build time, which means that we'd have to redeploy the website if we actually want to update this content. Now, we also have incremental static regeneration to solve the build time and dynamic data issues. So with ISR, we can decide to only pre-render certain pages and decide that other pages should only be generated on demand, only when the user requests it. So this results in much shorter build times, and it also allows us to automatically invalidate the cache and regenerate the page on a certain interval. So imagine if we wanted to show the individual listings as well and pre-render these pages to get a great performance when a user clicks on a listing, because we can pre-fetch that maybe when they hover a link or something. So with using Next, we can have dynamic paths with the combination of the getStaticPaths method to tell Next which pages to pre-generate based on their query parameter. So in this case, we're fetching all the listings and pre-generating all the pages. So if we had thousands of listings, this would take a really long time to build. So instead, we can actually tell Next to only pre-generate a subset of all the pages and render a fallback while the listing page is generated on demand. So the pre-generated pages behave the exact same, but if a user requests a page that hasn't been generated yet, isn't cached, it gets generated on demand by the serverless function. So this means that only a user in the region, or the first user that requests that page in a region, will have that slower response, because for everyone else, the page is already cached by the Edge network. So now our long build times have been solved, but we still don't want to have to redeploy the landing page every time to renew this data with the latest listings. So instead of only renewing the data at build time, we can also automatically invalidate the cache and then regenerate this page in the background on a certain interval. And we can do this by adding the revalidate field to the returned object. So now when a user requests a still page, so a page that has been cached for longer than the specified amount of seconds, the user first gets to see that still page, so they still see something. But in the background, a regeneration is triggered. So now the cache gets invalidated and it's updated with the latest page. So now when the user requests a page again, they'll actually see the updated content. So with incremental static regeneration, we can show dynamic content by automatically revalidating the page every number of seconds. And of course, this is already a huge improvement to what we had before, but we can still run into some issues here, because it's likely that our content doesn't actually update every number of seconds, which would mean that we're unnecessarily regenerating the page and invalidating the cache. And every time also we're invoking a serverless function, so this could result in higher server costs for no real reason. So the best option here is to actually use on-demand incremental regeneration. So with on-demand ISR, we can regenerate or instead of on a certain interval, we can regenerate based on certain events. So instead of relying on the revalidate field, we can manually revalidate the pages in an API route based on incoming requests. So for example, we can listen to an incoming webhook event that tells us when new data has been added to our data provider, and when we invoke the revalidate method, the page on the specified path automatically gets regenerated. Now, another huge benefit of on-demand ISR over regular ISR is the fact that this newly generated page gets distributed throughout the entire Vercel edge network. So with regular ISR, the return response only gets cached in the region where the user sends the request from. But with on-demand ISR, users from all over the world will automatically hit the edge cache without ever seeing still content. And we also don't have to worry about unnecessarily invoking the serverless function every number of seconds if content hasn't been generated, making it a much cheaper pattern to use. So on-demand ISR gives us all the performance benefits combined with a great developer experience. And we also don't have to worry about the high server costs anymore because we don't trigger a revalidation too often. And we can also bring a great performance to users all over the world with this edge cache. But of course, in a lot of cases, we don't want to just use static. For example, for highly dynamic, personalized pages that are different for every user. So in that case, we might want to use server-side rendering. So whereas we generated the HTML at build time using static generation, with server rendering, we actually generate it on every request. So this can be a great approach for pages that contain highly personalized data, maybe based on a user cookie or just any data that's contained within that user request. An example of a highly dynamic page is a dashboard. So this dashboard is only shown when a user is authenticated and mainly shows user-specific data. So with Next, we can server render pages with the get server-side props method. Now this method runs on the server on every request in order to generate that HTML. So now when a user requests a page, the get server-side prop method runs, and then the page gets generated and sent to the client. So now the client can quickly render this HTML and optionally fetch the JavaScript again. So the generated pages are unique to every request, meaning they aren't automatically cached by the Vercel Edge network by our CDN. This is the expected behavior, but that means that we have to do more or take more into consideration if you want to get a good performance. So when we look at the network and the main thread, it looks pretty similar to what we saw with static rendering. The FCP is basically equal to the LCP, and we can also easily avoid layout shift as we're not dynamically rendering content. But when comparing static rendering and server-side rendering, you see that the time to first byte can be very short when we statically render data, since it's already pre-generated. But when a page is server rendered, the time to first byte can be a lot longer because it, of course, still needs to be generated. So server-side rendering is, of course, a great approach if you want to render highly personalized data, but there's just more to take into consideration to get that good user experience. We might also, of course, run into higher server costs, and this is probably expected, but there are a few things you can do to optimize your SSR performance. Now, first, we have to, of course, make sure that the get server-side props method doesn't run too long. The page generation won't start until this method has actually resolved with data that gets passed to the page. Also, a thing to keep in mind, and that's often actually the cause of a long get server-side props execution, is the time it takes to fetch data from your database. If your serverless function is deployed to, say, San Francisco, but your database is deployed in Tokyo, it could take a while to establish that connection and actually fetch the data. So instead, you can consider moving your database to that same region as your serverless function to ensure that your database queries can be a lot faster. Next, you can also, of course, improve performance by adding caching headers to the responses. But if you find yourself doing that, your page might work even better if you use Vercel, if you use ISR. Because instead of not having to manually take care of the revalidation, the recomputed page will also be shared globally as opposed to one single region. But of course, ISR doesn't allow you to use that request-based data, so SSR is in a lot of cases still definitely the way to go. Now, next is something that's, of course, not as easy to do, namely upgrading the server hardware to get faster responses. Now, when you deploy to Vercel, by default, we use serverless functions for your pages and your API routes. And of course, serverless functions come with many benefits. You only have to pay for what you use. There are a few major limitations. A common issue, of course, is this long cold boot, meaning the time it takes up to start that Lambda. It's also not great if you're deploying a serverless function to, say, the US West Coast, and most of your users are maybe in Asia or in Europe. It might just take a really long time to actually make a request there. So a potentially more performant alternative, Vercel also offers edge functions. So when we talk about the edge at Vercel, there's actually a few different use cases and products for which we use the edge. Now, first, of course, the most straightforward one is the content delivery network. So on Vercel, the Vercel Edge network is used to automatically cache static assets to our users to improve that user experience. Now, of course, this is a very static approach, but there's also more dynamic approaches, because we also have Edge API routes. So when we talked about static rendering with that client-side fetching, we saw that we could use an API route to fetch that data from, which is by default a Node.js-based Lambda function. But we can also create API routes using the Edge runtime. I'm just waiting for that. So since Edge functions have that near zero cold boot, it doesn't take as long to fetch the data, which means that we can also reduce that largest contentful paint, resulting in a better user experience and also better core web vitals, better SEO. Next, we also have Vercel Edge middleware. So with this, we can intercept the request to, for example, check cookies or authentication state, really anything in the request before it gets forwarded to other resources. So this can be useful for things like A/B testing, authentication, bot protection, geolocation, you name it. Now, Edge middleware runs before the Edge cache. So this means that we cannot cache these middleware responses. So we have to make sure that the code within the middleware is very small, so it doesn't actually affect the user experience. Now, another thing we can do is, instead of having that rendering logic in a Lambda, we can move this to an Edge function instead. So we can even move some of the functionality, which we initially used that Edge middleware for, to the render function instead. But the biggest benefit here is that it uses the Edge runtime, which also supports HTTP streaming. So this means that we can use streaming server-side rendering, which is supported in React 18. So with the function hosted on AWS Lambda, we had to generate the entire page server-side and then wait for the entire bundle to be loaded and parsed on the client before the hydration could actually begin. But with Edge SSR, we can already stream parts of the document as soon as they're ready and also hydrate these components granularly. So users no longer have to wait a longer time before they actually can see something to the screen, because the components can just stream in one by one. And we can also use a combination of streaming SSR with React Server components. And this combination allows us to have this beautiful hybrid between static and server rendering. So React Server components allows us to partially render React components on the server. For example, if we wanted to show this landing page again, but now we wanted to show the region-specific listings to the user. So instead of having to server render this entire page, the non-dynamic parts, so the orange parts, can be statically optimized. And then we can just generate the dynamic parts or components server-side. Now this is different from the streaming server rendering that we saw before, where we generated the HTML on the server that then gets streamed to the client. Because with React Server components, we actually generate the React tree on the server, which gets sent to the client. So this is great if the component that we're server generating also has a heavy dependency, because we no longer have to download that on the client. We can just keep it all in the Edge function. Now, using this kind of static versus dynamic split in Next.js is still a work in progress, but I'll get back to that later. Now, of course, there are quite some constraints to using Edge functions. The near zero cold boot and the HTTP streamings are a big plus, but we of course have to keep in mind that we cannot use Node.js APIs. We cannot use Node modules with the Edge runtime, or anything that requires their APIs, like system or a path buffer and so on. Now, another thing, of course, to take into consideration is your data source, because we just saw how we could optimize this server rendering by moving the database closer to the Lambda functions. But if we now use an Edge function that still requires data from the data source, but your database remains in the same region, you might still run into a lot of latency issues. So in that case, using Edge functions might not yet be the best approach unless you kind of create a CDN for your database. Now, lastly, instead of being able to deploy 50 megabytes to an AWS Lambda function, we have to keep the code that runs in the Edge under 1 megabyte in total. Now, the Next.js team at Vercel is working really hard on the layouts RFC, which uses the Edge runtime with React Server components to enable a whole new routing system by enabling shared layouts between routes. I won't really go into detail for this RFC, but I highly recommend you check it out, because this is super exciting and it really shows kind of what Edge rendering can do. It's a whole new way of thinking about application architecture and rendering patterns in general. Now on Vercel, you can also find tons of demos and tons of different use cases if you're interested in seeing how your Edge or how you can use Edge functions on Vercel, also with some hands-on examples. Now I cannot change my screen here. Otherwise, I would have shown you how you can implement it either using Next.js or, of course, Vercel with the build output API, because we now support any framework to be hosted on Vercel as well, which all by default support edge functions, serverless functions, image optimization, anything you can name. Now, I know we covered like quite a lot of different stuff today. Of course, there's still a lot of progress also for Next.js and Vercel to be made in the edge world, but I think it's super exciting just to see how companies are using the edge today to provide a better and faster web experience. Again, if you'd like to know more about the edge at Vercel, I highly recommend you check out the documentation on edge functions, edge middleware, and also our custom edge runtime to see the current progress and also see what's on the horizon. I think that's all for today. Thank you for coming to my talk.